Right. Okay. It looks like we're starting, so everything is in place. The only question to our support team is just to share the not the presentation but the demonstration slide, please. And probably let us start. So we also see that not everybody from the registration list has joined. So we are waiting for the people to switch to the previous calls and to get to the audience of our webinar. Let us start probably with the topic and with several organization questions. So thanks a lot for joining our webinar. It is dedicated today to the webinar is dedicated to the topic of Android Automotive and titled "How to Make Android Automotive Audio System Play by Your Rules." We will, respective to the topic, today we are going to discover how to make Android Automotive Audio System play by your rules. And according to the agenda that was announced on the by the links that you followed, we are going to cover a range of very important topics regarding Android Automotive operating systems. And namely, they are the following. So we begin with answering to the questions: why should original equipment manufacturers and tier one suppliers invest in Android Automotive these days? Then we'll go to dive deep into the history of Android operating systems, to go quickly through the basic to more advanced features. We will also touch upon the current state of Android Automotive Audio, and closer to the topic of today's webinar, we will dwell on the out-of-the-box limitations of Android Automotive operating system, how to properly address them. We'll go through the difficulties with effective multi-zoning and auto differentiating for the drivers and passengers in a car with the out-of-the-box Android Automotive OS capabilities. And we hope we can have enough time to talk a little bit about the future. What's next for what is the future for Android Automotive operating system as a part of in-vehicle infotainment? And again, addressing the question to our team to share the demonstration slides. Let me also dwell on the organizational questions. So today's webinar is going in the format of one-way speaking, which means that all the materials will be presented by today's speakers. It will take us not more than 1 hour. We do not anticipate any interactive communications and questions on the run, but we more than encourage you to ask questions. And please, for that, use the chat box of the Microsoft Teams. And once the questions follow, we will during the Q&A session at the end of the webinar, we will answer them one by one. If we have too many questions for the remaining time, we will definitely answer them. So we will send a follow-up email with all the questions to the answers presented. So with this intro part completed, we have the audience of almost 60 people at the webinar, which is great. So let me start with the introductory part. So the presenters for today, starting from myself, Yevgen Mikhnenko, as me as well as my colleagues will represent the company Theater Every. I'm responsible for accompanying our customers on the journey of digital transformation and helping them to benefit from our solutions. But I will be probably the least speaking person today, and while the main webinar content will be covered purely by my colleagues. So let me introduce Piotr Krawczyk. Piotr Krawczyk is
nice to meet you.
Hi, Piotr. Thanks for joining. Piotr is the leading software engineer at our company Theater Every. Having, unless I'm mistaken, by the way, we need a proper slide here. Piotr, you are having more than 17 years of experience in this domain and in different, more sophisticated projects and startups. And also, the other speaker for today is Stefan Wysocki. Hi, Stefan.
Hi, hello. Good afternoon.
Yeah, Stefan is also the lead software engineer at Theater Every with 12 years of experience in this domain, as far as and also the experience with work with original equipment manufacturers and different projects related to Android Automotive. So that's our setup for today. Let us then move to the topic. And so now we're talking about Android, as it is one of the most desired and one of the most popular operating system on the Android on the automotive market. And let us probably start with the pros of using the Android Automotive system. Yeah, maybe Piotr, what would you say to that?
Well, Android already proved itself. It won a major part of the mobile market, and it is recognizable and valued among users. It offers also lots to developers and vendors, including a feature-rich framework for application development. This framework includes UI toolchain, window input management, audio management, media handling, connectivity solutions, security, app distributions, lots of things. So this is basically a complete development environment. Well, it also helps vendors and integrators offering advanced architecture focused on flexibility, portability, and maintainability. Well, Android proven to be also long-term solution for mobiles and other consumer electronics. All above are quite good references for the modern IVI solution designed to interact with the user.
Yeah, and as I know, Android Automotive has various technical limitations. Maybe Stefan, could you please share your opinion on this?
Yeah, so even though the Android right now covers the use cases for handhelds or other consumer electronic devices, it still has some limitations for the automotive framework. So we will try to cover it later, but I believe that the gap is going to be to be closed soon. So maybe if we go back in the history to overview the development of overall Android, we can find some similarities to the state that Android Automotive is right now. So at the beginning, the first Android versions were with limited functionality. So they were aimed to satisfy basically the phone functionalities. The broadcast internet was not that available, or was too expensive to be used in the same way as we are using it now. But so the apps were also the apps were also basic. So let me say vanilla Android brought almost nothing in comparison to the embedded systems used by the mobile phone manufacturers that time. Of course, it also required a lot of effort for the mobile phone manufacturers to bring it up to their platform. So what was good that time, then the idea to have like a common OS that developers can write third-party apps that can run on different mobile brands. So it was really cool. But in the reality, the SDK and API that was proposed to developers was not that great. But I guess it's normal for the first iteration of the system. So each next version was better and provided more clever solutions. So when the system was, let me say, mature enough, Google developed a parallel branch or flavor aimed for tablets. So perhaps it was hard to at the beginning to provide a system that would run both on mobiles and tablets. I guess that this setup provided some lessons learned for the product composition. So how to maintain the mainline, so enable or disable the features that would satisfy the sometimes completely different devices or use cases. So that is why from Android 4, tablets and mobiles were sharing the same implementation of the framework. So tablets gave us gave the Android some use cases that the mobile future devices could benefit until today, like multi-user management. For phone, it's unlikely that we will share it with the, I don't know, the householders, but for the tablet, it is possible that we would like to have like only one device and would like to share it across the users the same ways as we are doing for, I don't know, PCs, for example. But even with the fact that the main line of the Android was matured, there were still a lot of older devices with older Android on the market at that time. So the system was strongly coupled. That was actually the reason that the system was strongly coupled with the hardware. So huge involvement of OEMs was needed to actually upgrade it. To resolve the challenge from the developer's perspective, the Google or Android has introduced this compatibility libraries that provide some kind of a way to use the modern API and run the applications on the older Android. So under the hood the library was responsible for detecting which OS we are using and then translate it into the immature API if needed for from the older Android.
Yeah, but Google sees this flaw and tries to also support the vendors with their struggles. So with Android 8, the major change was introduced called Project Treble. Focus of this project was to isolate the vanilla AOSP framework from changes introduced by the vendors. So this was achieved by introducing binary communication between framework and the vendor house based on idle contract. So intention for this change was to make it easier to port the new versions of Android and also increase the stability of framework features. So in order to do that, new test suite was introduced that verify if HALs are following these contracted interfaces. And in the ideal situation, in the ideal world, so after such a check, your system partition with vanilla AOSP on top can fluently work with the vendor partition containing HALs, as long as those idle interfaces was compatible, and most of the framework services maintains backward compatibility to some extent, of course, by limiting access to new features.
Yeah, so you're right. So after the Oreo release, at least in theory, the upgrade of Android from version to version was easier for OEM. So in the same time, the system was attractive enough to bring more feature for the users, like multi-window, multi-display, multi-SIM card support.
I also remember that even before Android 4, there was already a phone with Android that was supporting multi-window mode. Were such features developed independently?
Yeah, so the feature of the multi-window was developed in-house by one of the phone manufacturers at that time. I believe that after they realized that multi-window will be available for out of the box for everybody, they faced a choice: either they continue to develop their, I believe, more advanced multi-window framework in parallel to the one that Google is doing, and somehow create some, I don't know, maybe a wrapper for the API that Google is proposing, or maybe fully abandon their in-house made code base and switch to the one that Google is providing. So there is always a risk that that when you develop some feature in-house without any plans to publish it, of course, it is of course if it is understandable, because you want to somehow differentiate your Android device from thousands of the devices, other Android devices that are already on the market.
Yeah, and interesting fact is that Google was not only watching needs of the CE manufacturers and try to extend its OS. There was already some interest in the automotive domain. I think that around 2015, Google introduced this Android Auto, which was a projection mode for a car. So that SDK dedicated to IVI manufacturers was released, and it allows to display content of application running on a phone on car's display. This solution is still used today, and it is quite successful. And this is a huge amount of new use cases like car navigation, media playback, voice calls in a car.
Yes, correct. So going back to the topic of Android OS history, I mean, not going with this projection mode. Now we are in the stage that mix of the features developed for tablets, phones, TVs, maybe some set-top boxes can be used to satisfy the automotive use cases. So I would say it is valid when you're looking for a car as some kind of a consumer electronics, but on the other hand, this is automotive. So we know that the automotive business is very specific and different than the consumer electronics. So it adds additional safety regulations, even for audio, especially, right? So it has a longer life cycle. It has more powerful. The audio system is more powerful than in a handheld. So somehow it is closer to TV, but still not close. And by this I mean it has amplifiers, some external sources, more speakers, and so on. So we are ending in a similar stage as I described on previous slide. So on the one hand, there is somehow a pressure from the industry for having Android in automakers' portfolio. On the other hand, there are already existing systems that are satisfying the industry needs for the future. So the automakers needs to evaluate if the AOSP code base can easily satisfy the feature needs, and evaluate how big effort is needed to adapt the open source code base to the needs. But we'll try to help you with that during this presentation, but at least from the audio perspective.
Stefan, Piotr, thank you very much for such an extended intro. It's really a very impressive history, and this is actually how the system got to the status where it is now. At the same time, our focus of the webinar today is rather about the automotive part of it, and let's move on and let's move to the digital cockpit, modern digital cockpit of a car with Android Automotive. And in that, it is rather or less about the visible components, but rather about the implicit parts. The question is, what is truly important and essential for the drivers and overall for the user experience? But let's discuss that, and I propose to dive deeper into the modern vehicle setup and have a closer look at what's going on inside the car powered by Android Automotive. What does the system offer and for the drivers and for the passengers? Passing the word to you guys.
Yes, so the cars from the top shelf already have multiple screens, and because of that, parallel users of the infotainment. So it's not really that the infotainment needs to be focused only on the driver. It could be also focused on it should be focused on the passengers as well. So the times when the driver has the power to control the radio are gone. So everybody is in control of a part of the card hardware. So the first thing that we are able to see is this digital cluster display. So according to automotive requirements, the contents needs to be rendered somewhere and ensure to display synchronized and accurate information. So this incorporating the cluster display into the whole system can be a complex task due to the let me say different hardware and software requirements. But we should not forget about the sound. So to provide the best audio experience, we often have speaker systems that are distributed through the vehicle. They can serve slightly different audio because I don't know, each speakers can be calibrated differently based on its position in a car or its size. So this might not be easy task to adapt the stream from sometimes one place like I don't know, stereo radio across and propagate the sound across the vehicle and make it still sound good. So additionally, we encounter the need for multiple microphones in the cabin. These microphones serve various purposes such as voice control, hands-free calling, and active noise cancellation maybe. So I would say that managing multiple microphones can be challenging, and it might be a common practice to reuse the experience of of already existing solution providers. So the effort would be to integrate it into the system. Of course, the complexity of the integration might vary. So sometimes it's just to integrate, but sometimes it's a complex task. So yes. We also marked here the rear seat displays, which is a common use case to provide entertainment purposes. So the comfort of the driver and rear seat passengers are important right now. So to enhance that, the modern car want to isolate the sounds between the parties, I mean the driver or the passengers. So yeah, we can start with the architecture of Android audio framework that is adapted to the core audio system. So Android overall supports various audio applications that can play sound in different contexts. So these applications includes media players for music, some kind of a system sounds for alerts and notifications. So phone applications can play a ringtone, or maybe navigation application might provide turn-by-turn direction. So each application operates independently and can generate the audio output. So inside the framework, the audio flinger manages the streams that coming from the application, mix it into the single streams depending on the context, but also is responsible for, I don't know, maintaining the volume. But it is more important for the handhelds when we do not have any external units for making the sound better, or some different sources outside Android. So basically, it provides the routing of audio that is coming from different sources to configure multiple buses. And here is it up to the OEM to transfer it from the native HAL component using this bus as entry point into the speakers.
So actually, this is a good example of previously mentioned treble project and isolation between AOSP framework and the vendor HAL. So application developers have stable APIs, so they can build applications portable across different platforms, different Android versions. On the other hand, vendors has clear interfaces based on contract between the HAL and the framework, allowing them to reuse the same code with different projects based on shared the same hardware, and it gives them advantage of quicker introducing new versions of Android because of this backward compatibility of many framework interfaces.
Yeah, so there is still up to developers what they will do with the audio streams that are coming from the Android audio framework.
Colleagues, thank you very much for the extended comments. So I propose now to sort of turn the page and now explore in a bit more detail what exactly needs to be, what has to be done to have Android installed. Are there any limitations that we can face during this process? Piotr, passing the word to you.
So yeah, the must-have addition to Android is ability to mix audio stream with safe sources. Android says QM domain and QM only. Let's make it clear. It won't handle your safety-related features, at least for now. So the sounds like a blinker or review camera sounds have to be somehow mixed externally, and it have to be handled outside of Android in a safe manner. Another often seen addition to Android, what we like to have on your platform is the extended volume management. So while Android has its own complex volume management, giving you also some opportunity to configure it, sometimes it is required to add some extra features like handling of multiple hardware knobs spread across the vehicle, some safe level of volume that is controlled by some external component, or the speed-dependent volume control that will adapt to your current speed or engine sound. So how to design platform needs more investigation. Choosing the right solution for the case requires quite a lot of decision. during the design phase. And to make those decisions, you need to have some clear requirements like audio quality level you are planning to have, what additional features you would like to serve, how much time or man or resources you have to deliver your project. So you must decide if your platform is a generic reference platform or maybe a specific product implementation. In the end, there is a lot of study to be done before starting even the design. When you have this knowledge, you can start designing your solution. And I believe that the first choice that you have to make is how to deploy Android. One option, so-called bare metal, means that the Android is running on their dedicated hardware. But one of the most common and trendy designs lately is to utilize highly efficient SoCs running a hypervised system where Android is living as one virtual machine and second virtual machine runs OS that manages hardware resources, safety-related features, this kind of stuff. This is often referred to as a guest and host partition or OS. And next step would be to decide how this external mixing of media with safe sources and audio processing will be actually done. Most common answer, use DSP. You can provide dedicated audio hull running on Android partition that will understand your DSP and can write audio data to its mixer interfaces. On the host partition, your component, well, let's call it chime generator, also understand your DSP and is able to write its data to it. So in this scenario, configuration is quite static, not so complex. However, the portability of this approach is not so impressive and tightly hardware dependent. Alternative to this would be to provide more complex architecture where dedicated audio subsystem and host partition abstracts this hardware DSP. Instead of directly communicating with the DSP, you can use interface of this component. This is a much nicer architecture, giving you more portability and also flexibility. This allows updates to be deployed much faster, as hardware dependency is concentrated in just one component, not spread across different software. And communication between partitions has already some proven standards like VCO sound in this case seems to be quite a good candidate.
Yeah, so it is worth to mention that such approach is being promoted by silicon vendors, since this is rather like hardware-specific solution. So on the other hand, there are like pure software solutions that are mostly proposed by the operating system providers, especially when talking about hypervised solutions.
Yeah, that's right. So another option would be to not use a DSP and let the CPU do the job. This is much less hardware specific, and usage of the software frameworks for managing audio will make the system less complex for debugging and maintaining, because it lacks the layer of managing the DSP, which can be really, let's say, challenging. On the other hand, it requires some more CPU usage and, what could be even more important, more power. And you must also ensure that your system will reserve enough resources to sustain constant audio processing. So now you have decided about processing. You've made your choice. Another major decision is how to connect the amplifier. The range of the solutions varies here. You can rely on purely analog connection. You just need some audio codec on SoC and a simple amplifier. This should do the trick for a budget-friendly solutions. But for more sophisticated setups, you can use Ethernet connection and delegate responsibility to amplifier of loading your SoC. It's quite more expensive because of the complex network infrastructure, more software components. And you have also some dedicated audio interfaces like A2B, which is a very trendy solution nowadays. So in this case, the connection is based on a simple pair of cables, allows you to connect components in chains. And besides synchronized audio data channel that transport your audio stream, it gives you also control channel for communication with peripheral chips. So using interfaces like this A2B gives you the opportunity to modularize your hardware. So Radio Tuner is a good example, as it is still kind of a basic audio use case in a car. I guess that's the first thing you will do when entering the car, just turn on radio. So instead of integrated in your SoC, it can be connected as a remote module and easily ported between platforms supporting A2B. And instead of maintaining your radio solution as a part of a SoC solution, it can be nicely abstracted into this broadcast radio HAL that have already some interfaces to the framework. And your tuner chip driver that will use A2B control channel to control your radio module. You just then need to configure a A2B stack to properly route the audio data to Android.
Piotr, thanks a lot. So now we're aware of what is required from the design point of view. What about some additional features that will enhance the perception of the platform and actually help to reach the modern audio experience in the car? Are there any additional components that have to be introduced in this way?
So example here would be the special content like multi-channel audio. This is already existing use case or already existing feature, but this kind of content or features needs some special attention and an additional design. I believe that in this case, it starts with looking for the content providers that are offering the chosen technology. Then you need some dedicated applications for this content management. You have to provide some custom services for Android, and maybe sometimes some specialized hardware that will support the decoding.
Thanks a lot for this comment. So it's time to move to the next, to move on. But at the same time, I would like to remind you it's half of the time spent planned for this webinar, and I see that there are questions starting and comments appearing in the chat. So I do encourage you to add the questions and comments, and we will dwell on them in the end. But yeah, let's move on. And as for now, we have covered the must-have efforts, what are required, what is actually required to bring the Android Audio subsystem to life. We also spoke about additional features that require cooperation with the content providers. Let's now switch to discussing more advanced Android Automotive features, and such as, for example, multi-zoning, a next-generation approach to in-car audio experience, where the sound is split into zones by design. The cutting-edge feature can help to manage commercial vehicles, as well as the entertainment for the rear seat passengers, as was mentioned already. I propose now to focus our discussion on this particular technical topic. And yeah, Stefan, maybe you can tell us more about this.
Yeah, sure. So to overview the multi-zone feature, we can start with the setup when only primary zone is active. So there is no additional zone, no additional user is logged in a passenger displays. So in that stage, the audio system manages audio sources. It also determines priority and then mix the sources into the adequate stream. And then deliver the mixed audio to the primary zone speakers, for example. So this allows the users to enjoy the different types of sounds like chimes, music, ringers, navigation that are playing in the same time. So I can add one assumption here. It will be simpler if we do not consider for now the additional mixing that might happen outside Android. So this was somehow mentioned or covered already by Piotr, and I'm sure that it is a starting point for different discussion, maybe for today. But to overview the existing multi-zone feature, I would say that we are dealing with let me say a non-safe car, or rather a custom set of tablets that can be installed by the user after the car is delivered to his garage. So when additional user logs in, and the parts of the car service responsible for tracking the occupants is able to separate the displays and assign the correct inputs to current apps that are running on these different displays. So by the input here, I mean I don't mean the audio input like the microphone, but I mean the touch screens or some additional hardware buttons like, I don't know, hardware back button, or more important to us, maybe a volume knobs. So to identify the specific occupant, this additional ID is introduced that is called occupant zone ID. However, it's somehow more correlated with the screens, with the displays. So for audio purposes, we need to take care of additional ID, which is audio zone ID. So it is used for the configuration of the behavior of audio routing in the multi-zone environment. So the bridge or the gateway for the audio subsystem, like the endpoint, are the buses. That was you might remember from previous slides. It was slightly mentioned. So based on car audio configuration and the information from the system, the audio finger is able to route the stream to the correct bus.
Yeah, the bus concept is very convenient for HAL developers. They don't need to worry about sophisticated logics of routing audio through attributes, context, zones. The framework is handling all those logics and, according to configuration, telling the HAL, please render this stream on this bus. From hardware perspective, you have to prepare output and input devices that can be different speaker sets specific for zones or different processing paths. The challenging part here is to properly configure all of the components. So framework configuration allows you to group and mix together audio coming from different applications according to its audio attributes into contexts like media, navigation, and so grouped in zones together. So that information is then assigned to the bus ID, and mixed audio stream is passed to HAL with bus ID information.
Yes, so indeed, yeah, the buses represent the parallel stream that can be used by HAL for different purposes. So usually, as you said, it means that some audio endpoints, but if you think about it as some kind of identification of the streams, then our audio HAL component or something outside Android can decide what to do with the stream from the bus. So, for example, we might create some additional bus that can be routed to the same speaker as stream from the other bus, but for example, might take different audio processing path. Maybe some low latency path, maybe some path that cannot be muted, maybe, or some specific effects might be applied, and so on. So here is the configuration XML that represents the two zones with multiple buses. As you can see here, the bus 1 and bus 2 are assigned to the zone A, and 3 and 4 to zone B. So it is chosen dependent on the context, of course. I mean, whether it should go to 1 or 3 or 2 or 4. So, but here on this example, it looks pretty static. We have multiple zones, and the audio connections from the apps to the buses are always the same. I mean that every time the music app on zone B would reach the speaker in zone B, but it doesn't resolve all the use cases that are popular, like maybe switching from the speakers to some private headset. So from the recent Android version, a useful feature that is called dynamic zone configuration might extend this static multi-zone environment to resolve some mentioned use case. So imagine the situation when you are sitting in the rear seat and wants to cast or play the same music with your colleague that is sitting somewhere in the other seat, but not so close to you. So it is valid, especially in a larger family car. So maybe some smaller buses that are running a single instance of Android. So we can configure the framework to have multiple configurations with different combinations that enable to route the context from zone B to the bus that was previously assigned to zone A. So the framework would mix it, and from the whole perspective, it would behave the same. So no implementation is needed on the OEM side for this. So there is additional API exposed by the framework, which is called Core Audio Manager Switch Audio Zone to Config, that can be rebranded into some fancy UI button with a naming like, I don't know, cast to front seat or something like that. So it's so this feature enables the use designers to create some derivative features, like maybe hijacking the music to be played for the whole car or so on. So, however, I would still call this semi-static since all the combination needs to be written in a configuration for each zone. So there is no way to dynamically change the whole device setup at random. So if you have like I don't know, thousands of seats, then you need to create like each configuration, each combination for each seat. So another use case is the mirroring that can be supported using this dynamic zone, but it introduces the problem with the application of the stream as we agreed together that for example if bus 1 represents the speaker A and bus 4 represents the speaker B. To play the music both on A and B, the framework was supposed to create two streams and route it into the HAL over bus 1 and 4. But there is no point, especially that somebody needs to synchronize the streams that would play the same at once. So by implementing this mirroring, by providing additional configuration, we can introduce additional virtual bus that can be used by the HAL to propagate the streams across different devices. So framework is informing the HAL which buses are mirrored, and this is done by this mentioned on the slide set parameters call that is perhaps well known, with the semantics mentioned on the slides as well. So HAL needs to parse the parameters and act accordingly. It can have like delegation it for the next external devices or maybe copy it inside Android.
So yet another example of utilization of this multi-zone feature and system APIs could be this example where already active tracks can be monitored by dedicated application and assigned to a available zone. So scenario could be that driver can actually switch song played on rear seat to all speakers so that anyone can hear it, or particularly he can hear it, or the way around, find song as a driver and play it on rear seats. So this is also possible.
Piotr and Stefan, let us make a short summary. If we want to have Android installed on board, so we need to provide the following three basic blocks, which are audio hall, external mixer, and configuration. Is this correct?
Yeah, that's generally the minimal requirements. There are already some offers on the market. Silicon vendors provide their sophisticated audio solutions promoting utilization of DSP, while OS providers propose CPU-based architecture. That's quite obvious choice. You can also design your own solution if you have some specific needs, and of course have time and resources. An interesting option is also to utilize virtualized house approach, like proposed in Android's child project. This gives quite interesting development options. Depending on your current needs, you can deploy it on a local PC. If you need to develop an app, or you can build your test farm if you need to have some more sophisticated verification strategy, or finally put it on a target hardware platform for final tests that cannot be executed on virtualized or on your test farm. Whatever option is chosen, final configuration needs some tailoring to OEM's need.
Yeah, so of course the wisest choice is to hire Tieto-Every, of course, but jokes aside, the integration is a challenging task, I would say. So there is no single solution for tracking all features, especially that they're coming from multiple ways. Like we have like features coming from Android itself, from silicon vendors, from OS providers, even from OEMs, and it needs to somehow we need to have like some experience to tackle it. But if you do it right, I would say that you might enjoy the benefits of open source components, especially that Android is one, as well as other GNU Linux operating systems that might be included into your car system, right?
Yeah, thanks a lot for this information. And Stefan, let me comment that this is half of a joke, half true. If you want an expertise, definitely one of the wisest choices would be to address Tieto-Every with such a challenge. But yeah, let us move on, and we are very close to our final part of the webinar, and this is about the future. So it seems that Google is now gathering more requirements from the vehicle manufacturers and tries to suit their needs by developing more new Android features from the version to version. Yeah, there is a lot more features to be implemented to meet the emerging in-vehicle infotainment demands. Addressing to you guys, could you please tell us what does the future of Android Automotive hold for the users? Which new exciting trends probably and use cases can we expect?
Yeah, so we live in a times when the artificial intelligence and the development of autonomous cars is progressing really well. So I would say that the cars will require less attention while driving. So the entertainment purposes will be valid not only for the passengers but for the driver as well. So I would say that Android is a one option, but I would not say that it's an only option to go. But actually, I do not see any alternative with the entertainment potential on the market right now. So now we are almost ready to make each passenger listen to their own music using their own streaming platform and play a video games that they are known from the tablets or from the mobile phones, especially when the game does not necessarily needs to be developed for specific OEM or even for Android Automotive. So I would say that any app that is designed for tablets can be reused for at least the passenger screens.
But that's a good point. Then a short question: why not just to install the standalone tablets instead of such complex solutions?
Yeah, but then we might even have more complex challenges, especially if we would like to satisfy the mentioned multi-zone feature. So then the OEM needs to invent some streaming solution between the tablets to the speakers and maybe adding some additional hardware. So all of those, and of course the shipment of the tablets or deployment of the tablets in the car might be rather expensive, especially in recent times when we suffer a hardware shortage. So when we focus on some kind of a high performance board, when we have only one board that will handle multiple operating system using the hypervisor, so it is less hardware needed but more software component that could be used for the software is better for upgrading, so they are able to be updated more easily than just replacing the hardware, or can be easily scaled to enable new features or even new operating systems.
Yeah, there are lots of advantages of hypervised system, and also addressing the comment from the comment section. About type 1 and 2 hypervisor. The comment is quite valid that at least in a production environment, the hypervisor of type 1 is mostly met. However, previously mentioned platform like based on the project like Trout, where the HAL-R virtualize allows to also utilize this type 2 hypervisor, for example, for development and prototyping phase. So with proper architecture, the Android instance can be run on PC or in the cloud. That definitely could speed up development and verification process.
Thank you very much, Piotr. Thank you very much, Stepan. So basically, yeah, we have covered the basic topics of our webinar, exactly what we have planned, and I'm really grateful for the information to you, Stefan, and to you, Piotr, and to everybody for the attention. We have 10 minutes to move to the Q&A topics, and Piotr, you already, I think, started answering some of the questions in the chat, and thank you very much, guys, for being active. Let us go through the chat. Maybe we'll cover them all today, all the questions. So I think that using HV type 1, that's exactly what we have brought a comment to, Piotr, right? If there is nothing to add more, then
maybe
sure.
just 30 seconds. So I've met also a situation where not even the type of 2 of dedicated hypervisor was used, but also the containerization solution was used, but this was rather kind of an exercise that in production environment. And when I was referring to host and guest, I would say that this is kind of a slang. So not definitely the host that is acting like a virtual machine manager, but in everyday work, it's quite common to refer to the Linux as a guest and to the host to some partition running something like QNX or other RTOS that has more focus on the hardware.
Thanks a lot, Piotr. So let us move on. As I understand, the next question is how transversal is the audio architecture? Is it specific to each OEM? Yeah.
I can comment. Maybe Piotr have different opinion, but yeah, if I would say like very strict, I would say yes, it is specific to each OEM, even if each OEM could go with the same solution, because we have different OS providers, we have different hardware providers, right? And as we already said, that some kind of influence to the architecture might be using the providers of the hardware and software. And at the same time, we have the set of challenges that was already mentioned that needs to be resolved. So there is no like silver bullet solution. So there is no like perfect audio architecture. However, I would say that there is from the Android side, because I don't know when the question was actually dropped during the Android part or no, but on the Android side, I would say it is pretty mature, especially that this is like a car audio framework is kind of supplement of the audio framework of the Android itself. So it still needs to be used for mobiles, for handhelds, for the tablets and so on. So yes, Google is willing to cooperate with OEMs to actually make the framework better. So to have the framework experience enough to not make any workarounds or any hugging solution outside Android, or providing some kind of wrappers maybe for the libraries and so on.
Thanks a lot, Stefan. The next question, are you aware of any platforms with Android that are actually using DSP for offloading work? It seems that most of them are still using the main AP cores. Yeah, any comment on that?
Yeah, I believe that there are this kind of solutions from silicon vendors. I don't want to promote any, but definitely one of the major ones are relying on the DSP and provide quite sophisticated architecture that is relying actually on its DSP and allows you to create a dedicated graphs for creating audio paths, and gives you the frameworks for managing those graphs from also Android. This is definitely quite complex solutions, and to fine tune is not an easy task. So again, yeah, hire us.
Yeah, perfect. For all your questions, please address to everything. But let's move to the question, to the next question. I'm really happy that more and more are added. How do you ensure your hardware supports multiple operating system changes and demands over time without the car owner having to replace the hardware?
Yeah, so I guess that's the challenge. Actually, I've heard it at the beginning when we start our adventure with introducing Android to automotive supplier. That was usually the first question, like, guys, stop. Mobile, you will throw out after 2 years, but the car needs to run after I don't know, the life cycle of the car, maybe 15 years right now is something like this. So yeah, if we isolate the hardware enough, I mean, that provides some hypervisor, then a lot of investment in the software, then it will be easy to have only one hardware, especially that right now the hardware is powerful enough to, I would say, satisfy the needs of the of the industry, I would say.
All right, thanks a lot, Stefan. Next question. What is your experience with, or describe maybe your experience with having the usual Android boot time and the time that audio becomes really available?
Yeah, that's quite a valid question. I believe that with last Android versions and with latest also SOCs, the boot time definitely increased. Still, there is quite a lot of work with optimizing the boot up process, and some tricks can be done with suspend to memory, with resuming state, with this kind of stuff. And for the early audio, these external audio sources are coming with a help. So all the safety sources that are required at the beginning of the boot are handled externally. So they can be handled by some editors, and they can be also handled by the DSP, which is available much before Android. On the other hand, when you would like to have your Android have this kind of early audio, you can also use two-stage hulls with an early audio hull that will serve the basic functionality, let's say, but will be available quite early. And then it can be replaced by the fully blown hull, including all your post-processing path, input path, and this kind of stuff seamlessly to have the audio in your IVI available earlier.
Thanks a lot, Piotr. So we have 3 questions remaining and 3 minutes left. Let us try to take maybe 2 questions more. What is your development tools which you are using? What are your development tools which you are using on daily basis? Is it Android Studio?
If I can say from my point, I still using. I don't want to promote any, but there is there is no, like, as I said, silver bullet tool because there is nothing to be promoted. So Android is built based on some kind of a build system that are already known for the industry. So for Java, yes, we are able we can use Android Studio. For the native part, C++, depends whether we are able to somehow convert the Android build system into some build commands that you can import into your favorite editor. You could use from the same family. You could use CLion, you could use Visual Studio Code, or some old-fashioned Vim, or for each. So I would say that this work as Android platform developer is pretty specific, because there is no always like a very well set up environment that you're able to work from the day one. So you need to cope with some limitations, I would say, from the huge code base, because I don't know, right now it might be like the Android might be like, I don't know, 50 gigabytes of the source code that you need to browse. So this is something that is impossible to be loaded into one IDE, I would say.
Thanks a lot for the answer, Stefan. So we have 2 questions left, and we have 1 minute left. So let me just announce the questions. The number 1 is that does Android Automotive incorporate any pre-processing for audio input, such as acoustic echo cancellation, noise reduction, or similar functionalities? Second one is, do you think it is a good idea to have Android on the instrument cluster side and have a proper audio experience, like volume control, etc.? And 1 more question added: does Android allow processing of audio streams at application and services layer? Let us please answer this question as a follow-up to our webinar. We will answer them by email, and everybody will receive the answers today. I just don't want to take any minute of your additional times. I would like to thank everyone for a very interesting webinar. Great information shared by our speakers and your activity in the chat box. We hope to see you, by the way, at the upcoming SDV Europe event on November 26th, going on in Berlin. When during the SDV Europe, you will have a chance to meet the Tieto Every team in person and discuss the future of software-defined vehicles, and ask as many questions as you want. For now, we would like to say goodbye. Thanks a lot again for your active participation. We would also be grateful for your feedback if it is possible to share in the chat box or anywhere. And yeah, stay safe, and hope to see you at our event. Take care.
Thank you.
Thanks, Stefan.
Thank you.
Pleasure to talk to you.
Bye-bye.
Take care, guys. Bye.
Bye.